Welcome to Spring LIB.
All right, so the number of wavelengths will just be the thickness of the plate or whatever material um, over the appropriate wavelength. Therefore, the number of wavelength difference between air and plastic, let's call it delta big N, is equal to the thickness in plastic over the wavelength in plastic, because that will be different than the wavelength in air, minus the thickness over wavelength of air, okay? So lambda p, so writing them down in terms of a common wavelength that we have, this is thickness times refractive index of plastic, n sub p, small n sub p, times over wavelength lambda, minus thickness times wavelength refractive index of air, which is actually just 1, over wavelength. And so this is T over lambda times NP minus 1. And that will be half a wavelength, as we found out, as the question wants, the problem wants. So this is 1/2. And so thickness is what we want here. So T, making that the subject, is lambda over 2 times NP minus 1. Therefore, this is 680 nanometers over 2 times 1.6 minus 1, 1.6 being the refractive index of the plastic, gives us 570 nanometers as the thickness.